Welcome everybody to the ESD's Brunel lecture for 2011. This is one of the Engineering Systems Division's signature events, along with the Miller lecture in the spring. I'm Joe Sussman. I am a joint faculty member in ESD in Civil and Environmental Engineering, and I'm serving currently as ESD's interim director. The Brunel lecture has been a tradition with the division, and it's very much in the spirit of engineering systems at MIT, where we are concerned with complexity and complex socio-technical systems. And this lecture, named for engineer Brunel, back who served in the profession back in the 19th century, is right on point with the kinds of things that he attempted back in those times. He was a cutting-edge thinker in terms of large-scale systems, in terms of thinking in a visionary way about how engineering could advance the human condition in the United Kingdom and, in fact, all over the world. And it included, of special resonance to me, a lot of railroad engineering. He built many railroads throughout the UK, and in fact, some of the roadbeds that are that he put in place back many a century and a half ago are in use now. Still, not the same infrastructure, of course, for high-speed rail in England. So this was a great man. I would like to think that if he lived in this time, he would have been an Olin College undergraduate and perhaps subsequently a member of the Engineering Systems Division faculty. Who knows what might have happened? So this lecture series, the Brunel Lecture Series on Complex Systems, as it is formally called, was made possible by funds assembled and underwritten by Frank Davidson, who is very well known for very large-scale engineering projects. He was the convener of the Channel Tunnel, or Channel as it's known, study group back in 1957, working with Bechtel and Brown and Root and Morris and Knudsen. Ultimately, that led to the construction of the Channel Tunnel and the high-speed linkages between Paris and London. Frank was a very distinguished figure during his time here at MIT. He currently lives in Concord, Massachusetts, but he is not a young man anymore, and getting into town is often problematic. He was a senior research associate here at MIT, which is the senior rank a researcher can reach, and served in a number of different capacities, particularly in advancing what he called macro engineering, the engineering of very large-scale infrastructure systems, which is, of course, of great interest even to the current day here at the Institute and at ESD. Our speaker today is Richard Miller, who's the president, the founding president, and to date the only president of Olin College. And he's going to speak about, from the ground up, a comprehensive systems approach to the redesign of engineering education. In fact, it couldn't be more appropriate from an ESD point of view to have President Miller here today, in that ESD is in the process of establishing what we have called our undergraduate footprint. We submitted to the Dean of Engineering just about a week ago our report entitled ESD's Undergraduate Footprint, with a 5-year plan for moving forward on the undergraduate side of the MIT spectrum. Our work to date has focused almost entirely on graduate education, and we are anxious to consider undergraduate options as well. So having a distinguished speaker like President Miller talking about redesigning undergraduate education is right on point. So President Miller was appointed president. He was the first employee, in fact, of the Olin College of Engineering in 1999. He's also there a professor of mechanical engineering. He's had a distinguished career throughout academia. He was the dean of engineering at the University of Iowa in the 90s, and prior to that, a number of posts at the University of Southern California. He's personally interested in a professional sense in applied mechanics, and has authored or co-authored something in the order of about 100 referee journal articles and other technical presentations. He has won 5 teaching awards during his career at 2 different universities. He received a Legacy Award from the College of Engineering at Iowa and the Marlowe Award from ASWE. He clearly has a great deal of distinction and much strength on the educational side, which I am sure equips him very well for the job that he has. He has an MIT degree in his background, a master's degree in mechanical engineering, and a Ph.D. in applied mechanics from Caltech. So, with no further ado, let me welcome to the podium, and I hope you will welcome him too, President Miller of Olin College, speaking about a comprehensive systems approach to the redesign of engineering education.
Well, thank you very much. It's a great privilege for me to be here. As a former MIT student, I never imagined the day when I would be invited to speak at this institution. And I think you might have made a mistake. You'll have to think about this at the end of the talk. Olin College is an unusual place. It benefits enormously from being so close to MIT, not just because of the distance, because of the influence. We have so many people at Olin who have degrees from MIT or were former faculty members at MIT. We've benefited enormously. And I'll tell you up front, Olin College never steals students from MIT. We borrow them. And we give them back to you as graduate students. In fact, if you look at the outcomes for Olin graduates, when they do go on to graduate school, and about 40% of them do, the school which attracts the largest number of them is not surprisingly MIT. Let me begin by talking a little bit. Well, let me also say at the beginning, unlike almost everyone else that speaks at this institution, I don't consider myself a scholar at what I do. I'm not an educational scholar. I don't have long publication lists in this field. I consider myself to be an educational engineer, and there's a difference. So my passion is about building things, and what I'm going to talk with you about is what we've learned in trying to build this institution. So let me begin by a review. Why is it that change is needed? If you're going to think about a systems approach to engineering education, you need to understand what engineering is and what needs to be changed before you begin to think about how to go about doing that. The National Academy, around the year 2000, when Bill Wolf was the head, did a review of the effects of technology during the 20th century. What were the 20 achievements that technology created in the 20th century that made the biggest difference for society? These, by the way, are conveniently available in a book, which is a wonderful coffee table book for anyone who's an engineer, who has an aunt and an uncle who doesn't know what engineers do. This is a great thing to have around. These are all things like electrification, the automobile, the airplane, the telephone, the television, spacecraft, the computer, the internet, cell phones, things that change the way we live so profoundly that few people can remember or even imagine what life was like without them. And that's a definition of innovation which I'm going to adopt. A really successful innovation is an innovation which changes the way people live so profoundly that they can't remember what it was like, what life was like before they came around. Well, after having done this, they also decided to look forward. What do you imagine will be the grand challenges that technology will have to deal with in the 21st century? So the Academy put together a committee and came back with these grand challenges, things like provide access to clean water across the planet. These 14 challenges can be grouped into 4 major groups, one of them about sustainability, another one about security on the planet, one about health, and the 4th one is either what we call the joy of living or the empowerment of the human spirit through technology. They have become very inspirational to the young people today. It's very hard to find kids graduating from high school who aren't concerned about life on the planet. They may not know what engineering is, but they're worried about sustainability, which is important. Do you know that last year, only 4.5% of the BS degrees in the United States went to students who majored in engineering, and it's a declining number. And yet, that 4.5% of the graduates is responsible for the lion's share of the economic development of this country. We need to do something to excite the next generation about what engineers do. And we believe that the grand challenges provide an opportunity. If you get them interested in the challenges and they discover that engineering and technology is necessary to address these challenges, they become seduced into this. In the same way that students that want to heal people who, make the lame walk and the blind see, go to medical school and they discover after they're there that they have to learn about biochemistry. Okay? You don't lead by saying this is a profession of biochemists. You talk about what you do in the end. This, by the way, led us to participate in the development of a series of national summits on the grand challenges. There have been a couple of those. This one happens to be a flyer from the last one in 2010, about a year ago at USC in Los Angeles. We're now in the final stages of planning another one, which will be an international summit, probably in the UK. So this series of challenges helps give you some template for the kind of problems that engineers need to work on in the 21st century. Let me reflect for just a second on a photograph. This is a photograph called the pale blue dot. Some of you probably know what this is. If you look very carefully, there's a dot on this photograph that actually is only about 1 or 2 pixels. It's a very special photograph. It was taken by NASA Voyager spacecraft in 1990, 41 astronomical units away from where we are, from our sun. That dot, by the way, is the Earth. That's us. That's the first time we had ever seen the Earth from a perspective of distant space. The person who motivated this photograph was, not surprisingly, Carl Sagan, who played a big role in the Voyager spacecraft program. And Sagan wrote a commencement address in Cornell, which I would like to just read a couple of sentences from, if you'll endure with me for a second. He says, "From this distant vantage point, the Earth might not seem of particular interest, but for us, that's different. Consider again that dot. That's here, that's home, that's us. On it, everyone you love, everyone you know, everyone you ever heard of, every human being who ever was, lived out their lives. The aggregate of our joy and suffering, thousands of confident religions, ideologies, and economic doctrines, every hunter and forager, every hero and coward, every creator and destroyer of civilization, every king and peasant, every young couple in love, every mother and father, every hopeful child, inventor and explorer, every teacher of morals, every corrupt politician, every superstar, every supreme leader, every saint and sinner in the history of our species lived there, on a mote of dust suspended in a sunbeam. The Earth is a very small stage in a vast cosmic arena. Our planet is a lonely speck in the great enveloping cosmic dark. The Earth is the only world known so far to harbor life. There is nowhere else, at least in the near future, to which our species could migrate. There is perhaps no better demonstration of the folly of human conceits than this distant image of our tiny world. To me, it underscores our responsibility to deal more kindly with one another and to preserve and cherish the pale blue dot, the only home we've ever known. If there ever was a compelling image for why a systems approach to the grand challenges of the 21st century are needed, this is it, okay? In fact, it's too bad we don't have Carl Sagan as we go forward. Now, one of the problems with systems thinking is that you discover the connectedness of things. The traditional approach of taking a problem apart and dealing with them one element at a time works well in certain areas of physical science, but it's a little more complex when the problems are connected. So unintended consequences are quite common. And we have an increasing need in the 21st century as the complexity of these problems naturally grows to prepare the next generation to deal with this complexity. And I will talk a little bit about schemes for dealing with that, but they have a lot to do with emphasizing the connectedness and looking for unintended consequences. Engineering innovators who make a positive difference in the world is the primary goal of our educational model. That's what we're trying to do. Now, let me talk a little bit about the educational role in preparing people for these kinds of complex problems, and maybe an unintended consequence of the way we have organized education. In this country, at least, most students go together in an educational environment in kindergarten through 12th grade, in which they have pretty much the same curriculum. They study mathematics, they study social science, they have some art, some history, natural science, and so forth. And then they graduate from K through 12, and they go off to college. And when they go to college, they major in something, okay? They might major in engineering and science, or they might major business and economics, or psychology, arts and humanities. On any major university campus, and I've spent 20 years at either a Big Ten school or a Pac-10 school, big campuses, 30,000 students, and there are recognizable quads on the campus where the engineering people hang out. And there's another quad on campus where the business people hang out, and so forth. And you'll spend most of your 4 years in that circle, even though it's like the University of Michigan. The engineering campus might be a mile from the library, and most everybody hangs out there, okay? While you're hanging out there, most of the subjects that you take have a particular lens on the world which you look through in order to conceive what needs to be done. In engineering, in science, it's mostly about feasibility. Most of the time we spend is looking at the world through the lens of what is it possible based on what we know about physical law for this thing to happen. On the other hand, if you're studying business and economics, the lens is mostly about viability. How does this enterprise work from the point of view of generating revenue, consuming revenue? Is there a balance involved? And then there's this other part of the campus which we in the sciences have a hard time understanding. And it's actually amazing because at least at Olin, and I believe it's true at MIT, I'll bet you well over half of your students are accomplished musicians before they come. And so they have a natural interest in this part of the world, even though it isn't easily accommodated within the natural sciences and mathematics curriculum. People who major in psychology and the arts and humanities have a different set of questions, not about whether it's feasible or viable. What is it that motivates people? Okay? What is the nature of beauty? What is the nature of love? What is the nature of trust, of justice? It's not about mathematics now. It's not about numbers. It's a more human endeavor. And so that's the kind of thing that motivates people who study those fields. Now, one of the interesting things is, if you look at the requirements for accreditation in, for example, an ABET degree, currently, I believe it's about 3/4 of the course credits that you take need to be in what we call STEM subjects, science, technology, engineering, and math, leaving about 1/4 of all the time you have left to learn about desirability and viability and everything else in life, okay? That's what it means to be specialized to become an engineer. It also means that as you go through this, all of your heroes, or 3/4 of your heroes, those PhDs standing in front of you in the classroom, have this lens of thinking about feasibility, and you pick up specialized jargon, you hang out with the same people. By the time you graduate, you are very much influenced culturally by the values of the STEM community, okay? And by absence, the interest and the awareness even of problems of desirability and viability certainly aren't nearly as well emphasized and appreciated. Of course, the same thing is true in business. To get an AACSB, a business degree, by accreditation standards, you have to spend half of your time studying things like management and accounting and so forth. And the people that you see as your heroes all have MBAs or Doctor of Business Administration degrees, and they have a certain way of looking at things. Half of it is left available for you to learn something about desirability and feasibility, although that happens relatively rarely. Finally, if you happen to be interested in art, for example, there are no accreditation standards for art, and therefore there's a wide variety of requirements. And in some places, it's possible to graduate, for example, with no exposure to feasibility. I happen to know this because I have a daughter who did this recently. Okay, she did really well. She graduated from a very fine private university in the Boston area about 3 years ago, cum laude, with a degree in economics and a minor in entrepreneurship, and she had not a single science course in 4 years. And the only math course that she took in 4 years was statistics. And it was a specialized statistics for the kind of major that she was taking. I talked to her about this. It's a very uncomfortable conversation around our dinner table, as you might guess. And she said, but Dad, I did well in my AP placement credits in high school, so what's the problem? Okay? The problem is, when she graduates, she doesn't have enough of an understanding about what the feasibility issues are in a complex problem to appreciate the contributions to colleagues from those fields around the table that are talking together. And of course, the viability folks don't understand enough about desirability. We've created communication barriers between the disciplines by the way we have organized ourselves in higher education. That's one of the observations here. So what? Well, here's what. So what is? If you look carefully, innovation always occurs at the intersection of all three of these things. My thesis is, I challenge you to think of a single innovation. Remember what an innovation is? It changes life so profoundly that people can't remember what life was like before it came up, that isn't simultaneously feasible, viable, and desirable. Okay? There are lots of examples of things, for example, that are feasible but not viable. Solar electric cells on the roof of your house is a good example. They've been around, they're technically feasible for many years. They haven't taken off and displaced other sources of electricity. Why? Because it's still cheaper to buy electricity the other way. It's not viable yet. And there are lots of cases even of things that are both feasible and viable but are not desirable. My wife and I figured this out when we moved to Iowa, where I was Dean of Engineering there for a while. Having grown up in Southern California, we're very fond of Mexican food. Okay? Guess what? The best Mexican food in Iowa, and I apologize for anybody who happens to be from there, is apparently Taco Bell in Iowa. So we had this plan, okay? We could create a Mexican restaurant in downtown Iowa City. We had the recipe that was a killer already. We knew what the business plan would look like in order to make this work. It won't work in Iowa City because folks in that part of the world just don't like hot food, Mexican food. It's just not desirable for cultural reasons. And if it's not desirable, you're not going to change the way people live, okay? You need all three. Educationally, this means you need to prepare the next generation so that they can appreciate and, in fact, contribute at the intersection of all three of these domains, even as they come out of the undergraduate program. I believe that it's easier to do that when you're 18 years old than it is when you're 28 or 35 years old and you have a family and you're worried about a mortgage, and now you're trying to learn something about fields that are more broad than the ones that you got as an undergraduate. That's why I'm so excited to hear about this ESD interest in creating an undergraduate program here at MIT. I think it would be a major contribution. Along the way, creativity and cognition turn out to be a really important recent set of developments and an important set of skills in education that I think every one of us in the education field needs to know. I got into this sort of by accident. For years, I've been telling my students, when you graduate with a bachelor's degree, you are not now an educated person. I don't care what the diploma says. You're beginning the marathon race. You haven't finished it, okay? You're going to have to learn new things for the rest of your life. So this is all about lifelong learning. So, excuse me, Dr. Miller, what does it mean to be a lifelong learner? Well, it means that you continue to read things outside of the field that you did your degree in every year. Okay, well, Dr. Miller, what did you read last year? Oops. So I decided to start putting a book in my briefcase every time I flew somewhere and actually read the thing. And try to do that at least 1 or 2 books every semester, nonfiction books about something related to the field that I need to learn about. In my case, why not education? I'm spending most of my time doing that. What can you learn? And it's amazing. It works. It really changes the way you think about things. So some of my favorite books, or last 10 or so, are up here. Every one of these, I could tell you for an hour what's in them, how they've changed the way I think. But there are 3 in particular, if you were going to start with, that I think educators should look at. This How We Decide book is about neuroscience and what it's taught us about the way the brain works in making decisions. And so many of the assumptions that we've made in the past about cognition and about decision making are just not borne out by what you see in an fMRI study of a person making a moral decision, for example. The same thing is true in this Norman Doidge's book about brain plasticity, which explains so well why if you learn Spanish in high school, you can't speak it now, okay? Because the memory allocation in the brain is a dynamic allocation which gets overwritten if it's not used. It gets reallocated to something else that's more important. How it determines whether it's more important is how often you use it. If you don't use it, you're going to lose it, okay? The human brain is the ultimate use it or lose it machine. So these are really interesting books. This one by Sir Ken Robinson is an absolutely must-read if you're interested in innovation. So here's a little bit of homework. This is a university, right? I always wanted to do this, to come to MIT and give somebody homework. Who could imagine? This is easy homework, though, because it doesn't require you to read, okay? What could be easier? You just have to watch a video. This is a TED conference video in 2006. How many people have heard of Sir Ken Robinson? Now, quite a few here, okay? This will change the way you think about creativity. I guarantee it. It certainly changed the way I thought about it. And the book goes in more depth about why our educational system has overlooked the contribution of experiential learning through the arts and how that could contribute to the development of creativity and skill. Anyway, a little bit of a deeper dive into the book in the upper left, this one by Howard Gardner on multiple intelligences, is useful. He was basically studying the validity of the IQ test. This was a really popular thing in the 60s and the 70s. Everyone believed that you're born with a certain capacity. It's a number. You could have it tattooed on your forehead, and it would tell you ultimately what you're able to achieve in life. Really handy thing to have if you're in a human assessment mode. So he was just doing some research to see how valid it is. One of the things that he found is that it's actually not very valid. In fact, the only thing that it does reasonably well is predict how well you'll do in the next class that you took. As soon as you graduate from college, it appears to have very little correlation with how you do in life. And then the more he looked into it, he discovered that there are lots of kinds of intelligences, and in fact, you can map them to regions in the brain and brain circuits that work independently, including linguistic and logical and mathematical intelligence, the kind that we currently measure in an SAT, which is predominantly the way we admit people to college today. But people have all these other intelligences too. This group, which I've called artistic intelligence, and another group, which I'm calling persuasion and management. These sorts of intelligences, interpersonal and intrapersonal, your ability to reflect on your own interaction with other people, is incredibly valuable for making an innovation work, right? You can't do this alone. You need people. You need to persuade others to invest. You need to deal with the cultural barriers to change. If you don't have a certain amount of interpersonal intelligence, this is going to be a disappointing outcome. And yet, they're not included at all in admissions to most institutions. That's, of course, glossing over this little challenge of figuring out how are you going to measure interpersonal intelligence. But anybody who's worked in a company knows you never hire the employee based only on the application for the job. You interview them. Why is that? Can you prove that you have a set of statistically valid tests that happen in the interview? Almost nobody can that I've talked to. There's a few companies that are working on that. And yet, almost every time we've interviewed for a faculty appointment, for example, before the candidates arrive, you take the resumes and stack them in some order, and you expect the one on the top, which maybe is thicker, to be the #1 candidate. And then after the interviews, you look at the order, it's never the same. Why? You learn something, I believe, about multiple intelligences in the people, about attitudes, behaviors, and motivations, which are actually at least as important as the knowledge that the person had if you're going to predict how well they're going to do. I have to just mention this book. This is by Mark Hardin. It's called The Curious Incident of the Dog in the Nighttime. This is one of the mistakes I made. This is actually a fiction book. Okay, I'm not supposed to read fiction books. But I read this on the plane back from Korea. It's about a 12-year-old boy that's growing up in England who's autistic. And it talks about what the world seems like to him, okay? And what effect his life has on his parents. It's a profound, gut-wrenching illustration of the pathology of what happens if you have a genetic deficiency in interpersonal intelligence, the inability to read emotions in others, which is basically what autism is about. It's a good thing this was an overnight flight, because several times during the flight there were tears running down my cheeks. I have a brother who has a special needs daughter, and so this is pretty close to home for us. These are very real dimensions to life which are just not in the mainstream of what we usually talk about in engineering. Maybe we should. One more book and then I'll move on. So this is the background, what needs to be done to change engineering. A New Culture of Learning. This is a book by John Seely Brown. How many people know who John Seely Brown is? Okay, several people, not necessarily the youngest folks in the crowd. John Seely Brown is the former chief scientist of Xerox, and he was the head of the Xerox PARC, Palo Alto Research Center. In his retirement years, he's become very interested in creativity, the internet, and education and learning. I highly recommend this book. It just came out in June. It's called A New Culture of Learning. So what does he say? He says, in the traditional model of learning, we think about it as transfer of knowledge from my brain to your brain, or vice versa. In the new culture of learning, it's about constructing knowledge on your own. People learn to construct their own knowledge. In the old model, we transmitted a can't-do attitude. You have to have all these prerequisites first. How could you possibly work on this engineering design problem? You're only a freshman. In the new model, you can do almost anything you can imagine. You have to work a little harder. If you haven't had the background, you find it out. In the traditional model, it's always about follow the orders. Okay? We're going to make sure they do the right thing, prevent cheating if you can. In the new model, you follow your passions, not the orders. In the old model, you learn in class. In the new model, you learn 24/7. Boy, is that ever true. In the old model, you learn alone, make sure that they don't cheat. In the new model, you learn in teams. In the old model, we worried about problem-based learning. In the new model, it's about design-based learning, which requires you to frame the problem before you solve it. You have to decide what is the problem. Much more creative. By the way, this isn't new. I don't believe that is new. I believe what that is a pedagogy very similar to what we've been doing for generations in graduate school. This is the way I learned in graduate school. In fact, when I was at Caltech, we didn't even have textbooks, and not one course. You all had to do reading. You had a lot of discussions and leading. You had to learn how to read things on your own, come up with questions, frame the problem, have a discussion with your advisor, eventually pioneer in the field. And the difference here is that kids are doing this when they're 8 and 9 years old. This is what the internet is making possible now. And so In fact, the most important quote, I think, in Seeley's book, very early on, he says, "For most of the 20th century, our educational system has been built on the assumption that teaching is necessary for learning to occur." Okay? What does that say about those of us who are teachers? Maybe there's a different role. Maybe it's not about simply transferring knowledge, but inspiring, coaching, advising in the way you might imagine doing this with graduate students. Okay, that's all about learning, cognition, the role of teaching. Another interesting thing is some work that was done here at MIT by Professor Warren Searing. You might have run into this. Woody Flowers presented this the first time that I had seen it. There's a thesis that was done by Kristen Wolfe in 2004, Understanding the Careers of Alumni at MIT's Mechanical Engineering. So it was about 600 alumni were surveyed 5 years out from graduation and asked them, what did you learn at MIT? What did you learn in graduate school? What did you learn on the job? What are you expected to know? What matters in your current job? And the overwhelming conclusion was what they learned at MIT was a lot about engineering science, and what they're using now isn't so much focused on engineering science. It's about other things. Things like what? Design, communication, teamwork, entrepreneurial thinking. If you want to see this really well done, much better than I would do it, another YouTube homework assignment, Woody Flowers, Professor Woody Flowers on education reform. If you search for that, you'll get a 40-minute talk by Woody who goes into a lot more dimensions of this, which is very interesting. So maybe the content of what we're teaching needs to be reviewed too. This is not just based on the survey of MIT graduates. The National Academy put together a panel to look at educating the engineer in 2020, composed of people from across many universities in the country, and guess what they concluded? There are some missing basics of engineering which are no longer included in the curriculum. What are they? Teamwork, communication, creativity, leadership, entrepreneurial thinking, ethical reasoning, and global contextual analysis. Interesting. We're all converging on this missing set of content, but we're all perplexed because there's no time in the curriculum to create a new course to do all of these things. So I guess we can't get there. That's what most of the conclusions are. By the way, we also discovered a lot of differences in opinions on what an engineer is. Okay? In my opinion, at least what I was trained to be, now that I've had some years to think about it, is actually an applied scientist. I think that's what I do. That's what I was trained to do. I know how to write papers, get them accepted in journals, about science applied to problems that engineers use. If you look in the dictionary, there's a slightly different definition here. A person who carries through an enterprise by skillful and artful contrivance. Where's the word science? Another one, you know, a designer or an architect of a system, process, or device. That's kind of what ABET uses. A project or team leader is a very common description that you hear from somebody in industry talking about what engineers are. One of my favorite definitions is this one. To engineer is to make, which is the subject of a commencement address at Olin by President Diana Chapman Walsh from Wellesley College, who is, in fact, an expert in English literature. To engineer is to make. There is a fundamental need in the human spirit to make things, okay, in which you don't know what it's going to be before you start. You get this image of a sculptor who starts with some clay, and you think you're going to make X, but halfway through it looks more like Y. And so you go with it, and you invent it in a new direction. That is, in fact, a really human enterprise which is closely related to engineering. So our current definition of engineering at Olin is more like this. An engineer is a person who envisions what has never been and does whatever it takes to make it happen, okay? So it's an empowering definition. It's a broad definition. You could replace the word engineer with the word entrepreneur and get to the same point. You could replace them both with the word artist in many contexts and get to the same point, which demonstrates the fundamental link between engineering as a profession and the arts. maybe engineering should be thought of more closely as a relative of the arts than it is in the sciences. So this is one of the other observations that we've had. The process of engineering design is actually a cycle. This is not news to anybody in this room, particularly the engineering systems division. It begins with a feeling that there must be a better way. Engineers are people who are never satisfied. Has to be a better way. Well, why not when you come up with an idea? In the engineering, if you are a real engineer and you have empowered this sense of can-do, you will try it. You just try it. You won't prove the theorems from the Navier-Stokes equations right from the beginning. You'll just build one, okay? And let's see what happens. And once you build it, you try it, guess what? Anybody who's an engineer knows it almost never works the first time. Something happened and it failed, and then you got this other idea, there must be a better way, and you just keep cycling through this. This is the engineering process. This is actually what engineers do in industry. Science is, in fact, power tools to help you do this quicker, not have to waste your time doing tests that are predictable, and so forth. But it's not, in fact, basically what engineering is. So the notion here is that engineering is a process, and the kicker is possibly not a body of knowledge, which our accreditation standards have sort of influenced us to think about. Engineering is, well, it certainly involves a body of knowledge, but maybe it's beyond that. There is obviously a similar process that goes on, but a different process in science. It always begins with an observation. Wow, did you see that? This is something unusual. Maybe it's because, and you come up with a hypothesis. Well, if that's true, then you should also see something else. So let's go find out. We do a test, and you find, what can you conclude? Oh, and by the way, did you see this other thing that happened that I didn't know before? And it keeps cycling. So one of the annoying things for grade school teachers of science is that science keeps changing, okay? Which is very annoying if you're trying to teach things as a body of knowledge. When I was a kid, you know, the human species was 1 million years old or something like that. Now it's much older because they found some other bones. So which is it? Those people in universities just can't make up their minds. Well, the reason is it's not a set of static facts. It's a dynamic process that keeps changing as we learn more. And that process is not emphasized much in the educational paradigms that we use. So this is now sort of a compendium of the problems. Along comes Olin College. Okay, so I'm living in Iowa City at this point in 1997, and I read a New York Times article that this foundation in New York has decided to reinvent engineering. It's a very interesting study. Doesn't happen very often. Didn't think too much about it. They said we need to create an entirely new paradigm for engineering education. I was working on trying to do that at the University of Iowa, finding all kinds of barriers. We don't have enough course flexibility to create a new course to teach entrepreneurship, and very frustrating. They said, we want to create an institution that has no tenure, no departments, no tuition, and continuous improvement. I said, wow, that's really different. Okay. And their founding precepts, they said, Olin College is intended to become an important and constant contributor to the advancement of engineering education in America and throughout the world. That's a pretty big idea for a little place. Very idealistic, forward-looking institution. Through a series of circumstances which are kind of hard to imagine, and my wife still thinks of this as my midlife crisis, I wound up going there, okay, as the first employee. And in fact, when I arrived at Olin, my first day at work was on St. Patrick's Day in 1999. Olin College was 5 people at that point, the 4 directors of the Olin Foundation and me. And we had to think of everything. I mean, we had nothing, we had no land. It was still an idea and not a place. So the big question was, where do you begin? You know, what do you do now? This is where the complex system comes in. If you make just sort of a parcel shopping list, You had to worry about leadership for this school, beyond the president. The president isn't going to have time to deal with most of these issues. Finances, governance, facilities, faculty, staff, students, public image, academic partnerships. Oh yeah, we need an academic program. Government relations, that's actually important. Accreditation, marketing. Nobody knows who you are. By the way, it was made more complicated by the fact that the F.W. Olin Foundation is well known for philanthropy in higher ed. It has given away 78 buildings on 58 university campuses that say Olin Hall. My office at USC was in Olin Hall. That's part of the reason why I came, because they had some credibility that these people actually do what they say they're going to do. But there's a real problem now in identity for the new school, which is called Olin College. Everybody says, yeah, I ran into that. Isn't that at Cornell or Johns Hopkins or Vanderbilt, or was it at USC? I can't remember. No, it's its own school. Well, which university is it? Public recognition is important too. One of the most important things that I learned is this simple thing in project management, okay, which is probably the first day's course in something that happens here at MIT, which a course that I never took, so I had to learn it the hard way. Basically, in the first 2 or 3 years, you will make tens of thousands of decisions, okay? Those decisions will have profound long-term implications, and you won't have time, you won't have any data, and you won't have time to have done a Ph.D. thesis on them. You just have to use your best instinct. And there'll be at least 3 variables that are in constant competition. One of them is quality or performance, another one is speed, and the third one is cost. And if you actually made a trajectory of how these decisions go over time, you would find that in the first year, you make more decisions driven by quality than anything else. But as you get close to the deadline, it's now driven mostly by speed, whatever it takes to get it done by Wednesday. And cost winds up driving before you get to the speed issue. If you really want, and here's we have been visited by 100 universities in the last 2 years. Many of them are involved in creating new programs in other places around the world. And one of the most common problems is that you focus on cost, business plan, and a schedule. And then as soon as you commit to that and you write this in black and white and you publish it, now your credibility is at stake if something changes, okay? And then quality winds up being whatever it is, it floats. So you can say, I'm going to bring in 100 kids next year. What if you only get, 100 applications? Are you going to take everybody? Because you said you were going to bring in 100. Does quality not matter now? What if instead you said, we're going to take in only the kids who have the following characteristics, and you define what you mean by successful students. And then the number of students is however many students you got in that particular applicant pool. It might be 10. There'll be budget implications, okay? But you'll set the definition for quality. So my thesis is, 10 years after you've started, and Olin has been going now for about that long, no one will remember whether you were over the budget by 25% in the first year. No one will remember whether you were a couple of weeks late in the speed, or even a semester late, or maybe even a year late. Everyone will remember the quality that you branded the institution with at the beginning. It's very hard to change the quality after it started. And I suspect this is true in projects of all different kinds. I'm just going to zip now. Simple strategies. Truly student-centered, not faculty-centered. There is a way of thinking about universities. They're all excellent universities are universally about excellent people, okay? And there's a certain ecology that's necessary to get them together and to help them to work successfully. And so you need faculty, you need students, you need a program, you need a reputation. One pathway to that is to say, well, what if we just recruited all the world's Nobel Prize winners? Okay, just start there. There's one path through this jungle. If you do that, what might happen? Well, probably the world's best students would want to be taught by the world's most decorated faculty. Who wouldn't want to learn chemistry from a Nobel Prize winner? Okay, and then by the way, money will probably come, because if you're looking at competitive research proposals, the person who has the Nobel Prize is probably pretty competitive. So maybe that's the pathway through. That's a faculty-centric approach. okay? Students are there, but they're a consequence of the people that you have in the faculty ranks. So Olin's inverted. What if we do whatever it takes to get the best students to come, and then the faculty that we want will be the ones who will be attracted to that mission of teaching those students? There probably won't be any Nobel Prize winners in that group, okay? That's okay. There's room for more than one kind of education system in the world. So that was one concept. Another one from a friend of yours, Desh Deshpande. In his talk recently at Babson at the Economy Conference, he said, I'll take the A team with the B idea over the B team with an A idea every time, okay? If you're trying to produce change in education, this is a really squishy thing. How are you ever going to prove that your way of learning was better or worse than mine? It's going to always be masked by the native abilities of students as well, right? So if you want to show the difference in the method, you'd better start with the A team. So Olin's philosophy is that we're going to get the A team of students and have them work on the A idea and see if that makes a difference in the marketplace. So we look for really good students, and we do our best to produce a really different way of learning so that we can compare them. Another interesting idea, which I'm now seeing 10 years out, advice from Joe Platt, the founder of Harvey Mudd College. There is no more powerful force for conservatism than having something to conserve. How's that? Okay? And he said, at the beginning, you don't have anything to conserve. People don't even know what you are yet. So you'll be willing to try anything. But he said, mark my words, in 10 years, there'll be certain things that are happening here that your whole community believes are absolutely defining of who you are. Now try to change. He says, you'll find your community is very resistant. You're worried about losing what you have. That's the definition of conservatism. And we're seeing it already at Olin, okay? I'm not popular for saying this in a faculty meeting, but I can see change over the 10 years. Key reading at Olin, I still meet with every new faculty member at Olin and give them 3 books at dinner on our first meeting. These are the 3 books which we all read when we were starting the school. Jim Collins' book, Built to Last. How many people have heard of that? Yeah, quite a few. He has a later one called Good to Great, which you might have heard even more about. Tom Kelly's book, The Art of Innovation. I'll bet you fewer people have heard of that. Some have. You know who Kelly is? You've ever heard of IDEO, the company in Silicon Valley, all about innovation? Talks about the organizational culture necessary to sustain innovation. And then Stephen Covey's book, Because Teamwork is Absolutely Critical. And unless you have some concept of your emotional interactions with people, it's going to be very hard to be successful on a team. Job 1 at Olin is core values, okay? It's all about trust, because you're going to have people doing so many bizarrely different things at the same time with no history and no background. There has to be a great deal of trust or it doesn't work. So we started, before we hired anyone, developing a very simple set of core values that we really authentically use. That's all I'm going to say about the complex systems part of it. So what is Olin today? It's, very simply you can read. It's not big. It's an undergraduate school. We're 48% women right now. We only give 3 degrees in engineering, 9-to-1 student-faculty ratio. We didn't have any graduates until 2006, so we have 6 classes now. 75 acres. Endowment is larger than $1 million per student, but I keep watching the stock market because it changes daily, and it's getting very close to going below that number. Research expenditures for about 36 faculty members is $1 million per year. We have a strong partnership with Babson and Wellesley, our 2 neighboring institutions, which complement us in important ways. And of course, we have no departments, no tenure. We can't be free anymore because of the financial crisis, but we're cheap, okay? And we have a very serious commitment to continuous improvement, which at Olin means everything has an expiration date, okay? Even the bylaws for the Board of Trustees has an expiration date. The curriculum has an expiration date every 7 years. Which doesn't mean that we throw everything out, but it means that none of us at Olin has tenure and nothing at Olin has tenure. So don't assume that you own this course until you die, because we're all going to rethink it periodically. That's what the campus looks like. Actually looks pretty much like that now because this was taken in the fall. Where are we? You know. Where do the students come from? This is a map that shows where the students come from. The interesting thing is we get more students from California than anywhere else. We get a lot of students from Texas, quite a few from Washington State, from Illinois, from Virginia, New Jersey for some reason, and of course Massachusetts. In our first year, getting a student from Massachusetts was a diversity goal. Okay? If you're too close to home, people don't know who you are and they don't believe it. Now we have quite a bit from there. So our neighboring institutions, remember feasibility, viability, and desirability? That's where our kids get it. And they all cross-enroll for free. Olin students do about 10 group projects, and we do as much as we can to make those teams multidisciplinary, completely outside of our institution, getting kids from other institutions involved. Some features of the Olin curriculum. We look for multiple intelligences. Nobody gets admitted to Olin without going through Candidates Weekend, which is a series of interviews over the weekend. So we get about 1,000 applications. About 200 of them are pre-selected for interviews over 3 weekends, so that means about 70 per weekend. And we run them through a whole series of group exercises and ask them what their passions are in life, have them negotiate a position on a complex issue like the Iraq War, and then we have a diverse team that votes on whether we think they're a good fit for the school. Extensive design core. We believe that we don't need to just duplicate what Caltech and MIT do. You guys do this terrifically well. The world needs diversity. We need a different approach, so we made design the core in our program. So there is a design core that begins in the very first semester and it goes continuously through all 4 years. And it gets more complex as you go through it. Oops. It ends in a senior project on steroids in which students work for a year for a company. The company is paying $50,000 for the product. There are often patents involved. New technologies occasionally develop out of this. One of the problems with engineering education is that engineers don't know how to communicate very well. There are lots of jokes about this. You probably know the one about how can you tell the extroverted engineer when you're in a group? He's the one who's looking at your shoes when he talks. Okay? So what are we going to do about that? Well, at Olin, we've developed a program where at the end of every semester, every student has to stand and deliver to the entire community over a 2-day period. Okay? We run it like a big national conference. There are about 100 visitors from industry that come, and they all get feedback. They don't get a grade, but they all have to do this. And there's nothing more threatening when you're 18 and you're a freshman and you have all these seniors and all the faculty out there than stand up in front of a group and have to answer questions and deal with it live. By the time they've graduated, they've all done that 8 times. And I think that's one of the most transformational things that we've seen in our community, because by the time the kids graduate, they have a great deal of poise and an ability to answer things on their feet, which is really important for being an engineer. They have to learn how to learn. The Olin self-study, they have to complete a project for which they do not have the prerequisites, okay, deliberately. They have to learn how to find the material that they don't have to demonstrate that they have an answer to it that is validated by somebody who does know the field. You have a capstone in either entrepreneurship or arts and humanities. All students must start and run a business for a semester before they graduate. This is project-based learning in business. It's amazing how hard it is to get people to part with their money, okay? That's the main lesson of this. You have this really cool idea, and maybe your dad or your mom will, buy one. But if you have to sell it to somebody who's not a relative or is not your roommate, which is a requirement in this course, you learn an awful lot about marketing, persuasion, interpersonal intelligence, and all of that. Okay, the learning culture is far more important than the curriculum. This is not my words. This is Chuck Vest. If you read what he's written a number of times now, it's not about the curriculum. It's about the milieu that you create in the campus where people are curious and they're driven by a passion to learn. That's what this is all about. in the same way that the strategic plan isn't nearly as important as the culture that you create in the community. The plan is a means to get you to that end, to the culture. It's not the end. So that's the key learning here. Does it work? And I'm almost done, for those of you who are snoring now in the back row. Overall, and this is reflections on the first 6 graduated classes, I think it exceeds our expectations. It's not perfect. There are lots of things that didn't go the way we expected. There are a number of things that went way better than we expected. So far, there are more of those than the others, but that's lucky at this point. One of the big questions is, how do you assess this? How do you assess any psychological or educational experiment to know whether it's better or worse than something else? And is it scalable? Can you do this anywhere else? It just only happens at Olin. And as I mentioned, we've been visited by 100 universities. We have partnerships now with 9 other universities that are using forms of our curriculum. The most mature one is at the University of Illinois at Urbana-Champaign, where all 1,500 of their incoming freshmen this fall are taking a program which has 3 of our courses embedded in it. So we're still working on that. We don't know how scalable it is, but we're interested. Last point, student engagement. I still think it's about this milieu of excitement, passion, and creativity. And that only happens if the students take responsibility for their learning, so that it's not the teacher's job to teach the students, it's the student's job to learn, and the teachers are there to help. If you can achieve that, you unleash forces which really are power tools. And so how do you know if you did that? Well, actually, there's a group of folks at Indiana University in the College of Education that have been working on this. They've developed a national survey for student engagement. How many people know about this already? There's probably quite a few people. It involves, I think last time they did it, more than 500 universities and 500,000 students. They assess, there's this long questionnaire. They assess them as incoming students. They assess them as departing students. They lump the categories into 5 areas. The results for Olin are really stunning in this area. The kids really are engaged in their own learning. And here's an example of some statistically normalized scores across this set of data. The blue bars are the Olin scores. And I can say this in this audience, you'll know what this means. This is Olin's score minus the mean score for the global population divided by the standard deviation of the global population. So this is the deviation from the mean measured in units of standard deviation of the whole population. So Olin's about 1 standard deviation above the mean everywhere. What are these other things? Well, by this metric, the little red squares for all universities are defined to be 0. The yellow bars are for a group of about 20 selective private undergraduate engineering schools, some of which we compete with very much for students. Not MIT, these are undergraduate programs. The green bars are for a group of selective liberal arts colleges, like the NESCAC schools, for example. And so there you see Olin's results so far. By the way, I'm particularly proud of this active and collaborative learning thing, because I think that's very close to that definition we had before. To engineer is to make. That's what they're doing, and that's what they're passionate about. And if you're still awake and have any time, I'd be glad to take a question or two.
Well, thank you, President Muller. That was an excellent and inspiring talk. I'm sure we'll have many questions from our audience. So let's get it started. Oh, there you go, Olin.
Could you go back to the slide, the positives and the negatives? Because some of the negatives that you had under the negatives column actually looked like positives to me. But maybe you could just talk through these one by one a little bit.
Yeah, and this is not a unique list. It's probably a much longer list than this as you could go through too. Some of our concerns about balance. We have decided deliberately to emphasize design, and that means that every student has to take this core program in design, but then every student doesn't take every course in differential equations and every course in thermodynamics and all of the rest. So the question is, did we go too far? Have we eliminated so much of the the advanced technical electives in the junior and senior year that are so common that certainly I had up the wazoo at Caltech. I'm afraid that those folks will disown me for what I'm doing. Maybe we're doing damage to the students. Okay, how are we going to know? So that balance of qualitative design versus quantitative is an issue. Our best take on it so far is we're watching like a hawk what happens to Olin graduates when they go to MIT for graduate school, when they go to Caltech, when they go to Stanford. Do they pass the qualifying exam? Do they get blocked at that level? How many of them just drop out because it's just too hard? And so far, I don't know of a single Olin student who has failed the qualifying exam. But I also don't know of a single Olin student who's come back to me and said, boy, was that a piece of cake. Making that transition to MIT was nothing, man. I just was perfectly set up. They have horror stories about how difficult the transition was. So I know that there's a balance here somewhere. Student interest grows beyond engineering to include leadership, policy, and management. Sounds like a positive, right? What happens, for example, our first graduating class, one of our most successful students is now a film producer in Hollywood. Okay? I got a video from him this week. He created a documentary film called Under the Boardwalk, which is a documentary about the game of Monopoly. Okay? Who knew? There's a world competition in Monopoly. So he's been all around the world filming this thing, and he's collected enough money to create a professional production. It's been showing now in New York and in Los Angeles, and I'm proud of that. I'm not so sure everyone who thinks of engineering in the traditional applied science way would count that as an engineering outcome. We have another graduate in the same class who's an actress. Emma Goodman. Her father is a physicist at Fermi Labs. And she's supporting herself in Boston and New York with, I think, very meager income, maybe also waiting tables on the side. She's passionate about drama, okay? We have quite a few people who have PhDs now. We're seeing them. The first one was a kid from Cedar Rapids, Iowa, Michael Curtis, who got his PhD in 2009 from Oxford in physics, and he's involved in a startup company. Well, that's at least in science, okay? Babson College now has a new professor of mathematics who got his degree from Olin in 2007, got his PhD from Cornell this past spring, and so he's teaching math there. So they do weird things, okay? I think that's probably true at MIT too, but it feels like that the standard deviation is a little wider now because we've encouraged them to do this. So be careful what you ask for, I guess, is part of the thing. Alumni preference for small startup companies. This, I think, is a good thing. I mean, that's what the school was created to develop engineering innovators who will create new technology companies that will employ people in the future. That's normally going to happen with small startups. However, we have a number of kids who I think should have gone to MIT for a master's degree first, and then maybe work for IBM for 5 years. And then I think launched a company, they would be able to make a much bigger difference. But I'm old, okay? And a little bit too traditional maybe. These guys, we have a group of students who started and got very excited about saving the planet and green technology. So they've made a solar-powered trash compactor, okay? And immediately got involved in this and didn't think about graduate school, and they've been running it now. In fact, they sold it to one of the large waste management companies. And I think they'll outgrow it, and they'll eventually decide, well, that's cool. I understand the process of engineering now. I understand the process of innovation and entrepreneurship. So now I need to go back and learn a little bit more about science so that I can do this at a higher level. So my concern is maybe if they drop out of school in the 6th grade, they don't all turn out to be like Steve Jobs or Bill Gates. Some of them would have been better off to stay in school. And I feel guilty for having encouraged that. So that's part of it. Assessment, again, how do you know that it's working? We're constantly obsessing about that. And growing resistance to change, which I already mentioned. Okay? Any other questions? Yes, sir.
On one of your bullets mentioned the junior year study away.
Yeah?
Can you talk a little bit more about that and what that entails?
Yeah, study away in the junior year. Olin's curriculum is designed so that every student can study away for a semester in the junior year and still graduate in 4 years with every major. You have to plan for this. You can't wake up in your, the beginning of your junior year and say, oh, I'm going to change plans now. I want to go study abroad. But if you start thinking about it in the sophomore year, you can make it work. About 25 to 30% of Olin students actually do this. And then we have a group that do something like this, which, and this is, I don't want to get too detailed in it, but Olin's tuition model, by giving everybody the scholarship, they have to spend one of their semesters of free tuition by studying away. Some of them get so excited about the courses they're taking, they don't want to give up that extra semester of free tuition. Since it's low cost anyway, they decide to just take a leave of absence. Okay? So they're still going to go to Olin for 8 semesters, and they'll extend their education by 1 semester and do this thing else that they want to do. Then they're not bound by the business that it has to be a transferable credit from some other university. They can do whatever they want, including start a business, which they sometimes do. We had originally envisioned that every student would be required to do a study away. We have had lengthy discussions about this. It happened that Olin had students, excuse me, for the first time in the fall of 2001. So September 11th came, and Olin did not yet have permission from the Immigration Service to grant student visas. And they said the Senate is in the process of making a change to all these rules, so don't even think about it, okay? We are not going to approve any new university having the ability to bring in foreign students, not at this point. So go away and don't come back until you're accredited. And so we put this whole issue on the back burner, which is unfortunate, because it didn't get any attention. We developed other things. And now we have a tradition that's built up, and a certain percentage of students go. And now to increase it to 100% would be a big issue. But it's still on the radar screen. But now we need revenue for it to make it possible for students to do this.
Rick, I'm wondering if I could pose the moderator's spot. Where do you get your faculty and how you recruit them for this very special environment?
Yeah, that's a really good question. Faculty recruitment is absolutely key, of course. Frankly, I don't think Olin would be nearly as successful if it had happened to be located in, say, Kansas, okay? Being located in Boston area is like being located in the Silicon Valley of higher education. So we've been benefited by people who had relocated to this place to start with. We do the same kinds of things that you do in terms of advertising. The school got a lot of media attention from the New York Times, the Wall Street Journal, and so forth, so there's some name recognition out there. But there's maybe some credibility problems. We put ads in the, ASEE, IEEE, ASME, all of the major things, and we get about an average of 140 resumes per faculty position at this point. Obviously, in fields like sociology, we'll get 500 applications. In fields like wireless communication theory and EE, we'll get 50 applications. It varies, but on the average, it's a little over 100. We interview them slightly differently. They have to have a strong commitment to being thought leaders in their field. So we expect them to continue their research, not at the same pace that they would if they were at MIT, but the quality of what they do should be equivalent, okay? So in a 5-year period at MIT, a person might have 25 papers. That's sort of a threshold. At Olin, in a 5-year period, it might be 5 papers. But when we write to the journal editors and we ask them about the quality of the work that this person has done, we expect them to say it's equivalent to the quality of the work that we saw from a faculty member at MIT, for example, just not as much of it. But the most important thing is that on the interview, they don't just present their research, they also have to teach, because that's what we're about. So we schedule them to actually teach a live course with students that are currently enrolled taking a subject in the field that they'll be assigned to teach. We'll tell them what it's about. If they're a mechanical engineer and they're in thermal sciences, we'll tell them you're going to teach thermodynamics, okay? This is the first course in thermodynamics. We're using these kinds of materials. We're going to be talking about the second law on the day that you're there. So we want you to come prepared to wow our students with your inspirational teaching on the second law of thermodynamics. And then after the class is over with, we enlist the whole class as part of the interview team. And we ask them essentially, Is this an inspirational teacher? No. Yes. Do they have the capability to be better than the teachers that we have here? And we take that very seriously. And sometimes it becomes a bit awkward, okay? We've had advice from a very good friend on the faculty at MIT. We pleaded with them for 2 years to get us somebody that was a former student that was really good at what they did. We came and interviewed. He's spectacular. But the students did this, okay? And we wound up not hiring him. And now I don't think we can go back to this faculty member at MIT and ask for any more names, because I think we've probably gotten him in trouble too. It's complex. But that's basically the process that we use. One last comment. Does Olin buy faculty members? You know, like, do we triple their salary? And that's how we got them to come without tenure or a PhD program. And the answer is no. We benchmark our salaries against a group of 33 schools, and this includes MIT and Caltech, but it also includes think places like Harvey Mudd and Rose-Hulman and Cooper Union, and some liberal arts schools. And the average salary for faculty members at Olin is about 104%, so it's like 4% above what the average salary is for this aggregate group. So it's about the same. Okay?
Take one last question.
How does the faculty member get the research done?
How do they get the research done?
I mean, you have graduate students or the undergraduates do the research?
Undergraduates do the research. So we have to be a bit careful. If the faculty member has a research topic that involves a heavy amount of experimental work in a clean room with postdocs, this is probably not a good fit for Olin. If the faculty member does research that's primarily in applied mathematics, for example, undergraduate students can do that really well. And we have to be careful that that doesn't bias the type of education that they get, so they don't get any exposure to certain kinds of experimentation. So we're working on that still. You bet.
Rick, thanks so much for just an excellent talk.
No, thank you. Sure.
Our traditional gift at these lectures, you can now look at yourself anytime you want with the poster that you've seen all over MIT. So take that home and enjoy it. I have a very special challenge in the spring. I mentioned at the outset that we have 2 signature lectures in ESD. We have the Brunel in the fall, and we have the Miller in the spring. So I had a Miller give the Brunel. So if anybody knows of a good Brunel who I can ask to give the Miller, we'll have perfect symmetry. Thanks for coming. Thanks so much.